Good morning, students. So in last class we are discussing about complex compounds. In complex compounds, important points we seen. What are that? First one, central metal ion. Next, second one, so metal ion oxidation state. Next, third one, ligand. Next, fourth, coordination or complex sphere. Fifth, coordination number. Next, homoleptic. So homoleptic complexes and heteroleptic. So these are we discussed in this central metal ion oxidation states are over, ligand also over. Now we are going to discuss about a complex sphere. So complex sphere. See, it is the combination of central metal ion, combination of central metal ion with ligands. So complex sphere is a combination. So combination of central metal ion and ligands. So these are indicated with square brackets. So it is indicated with square boxes. In what way you can write? So metal, some ligands are surrounded with a complex sphere. This complex sphere either neutral charge, otherwise it has positive charge, otherwise it has a negative charge, depending on the oxidation state of the central metal ion. So this is metal and some ligands. That combination we are showing with the square brackets. This combination you call as a complex sphere. In the solution state, it is non-ionizable. So in the solution state, so complex sphere is non-ionizable. So already starting only we discussed K4FeCN taken 6, potassium ferrocyanide. So you take this compound, you treat into water. Then what happens? Outside potassium coming outside as potassium ions. But this iron cyanide, these are not coming outside. So how you can write FeCN taken 6 minus 4. So this is called as a complex sphere. So here now it has 4 negative charges. So it may be negative charge, it may be positive charge, and it may be neutral. So many examples we can see in the future also. So this is about a complex sphere. Next, coordination number. Next, fifth, coordination number. See, the number of ligands. The number of ligands present in complex sphere. See, the number of ligands present in complex sphere, otherwise number of ligands surrounded to the central metal ion. So R. The number of ligands surrounded to the central metal ion. So in complex sphere, so this is important. See, suppose this same example only you take K4 FeC and taken 6. Iron is surrounded by 6. So the coordination number is equal to 6. So that suppose the different examples we see means see Ag NH3 taken twice Cl. So the metal is surrounded with 2 ammonia ligands. So coordination number is 2. Next is suppose you take zinc. Zinc surrounded with 4 water molecules. So this 4 you call it as coordination number on plus 2 zinc. So in complex sphere, number of ligands surrounded to the central metal ion is called as a coordination number. Next, homoleptic and heteroleptic complexes. Next. Sixth, A. Homoleptic complexes. So the homo means what? Same. So leptic means ligands. So same ligands are present in the complex. So that is the complex in which which has same type of ligands are called as homoleptic complex. So example, if you see that only K4 FeCN taken 6. So the metal is surrounded by 6 cyanides. All of the 6 are also cyanides only. So same type of ligands surrounded homoleptic. Next, heteroleptic. The name itself, hetero, means different. So heteroleptic complexes. The hetero means different. Different leptic means ligands. So the complexes which contains different ligands are called as, suppose same thing only, I am taking K4 Fe Cl2 Br2 I2. If I am taken. So then what happens? 2 chlorines, 2 bromines, 2 iodines. So around the metal different ligands are present. So then it is called as a heteroleptic. So how to write that one? The complex in which has the same type, but here you write different type of ligands are present. Then it is called as heteroleptic complex. Next, after this, we are going to discuss about ligands in detailed manner. Already we discussed about ligands. So once again, different. How many types of ligands are there? So that is very important. In future we are going to discuss about nomenclature. Nomenclature of the complex compounds, in that also. The ligands only key role. So that's why now the important concept, that is the ligands. See, already we discussed which one you called as a ligand. the electron pair donor. The electron pair donors are called as ligands. See, these ligands are classified into classification of ligands. See, dentate. So dentate means donation. So based on the dentate means donation. If one lone pair is donated, so that is called as monodentate. Monodentate ligands. Next, bidentate ligands, tridentate ligands, tetradentate, next pentadentate, next hexadentate. So up to 6 are more famous. So based on the dentation means or donation, monodentate ligand means one lone pair is donated, bidentate ligand 2 lone pairs are donated. Next, another one. See, second category. So this is available either positive, negative, neutral also. These are available as positive, negative, neutral. See, this combination also we are linked up with positive monodentate, negative monodentate, neutral monodentate, like that also. Next, so flexidentate ligands. So the name itself is flexi. Flexi means suppose a hexadentate ligand is there. That meaning is what? It donates 6. Suppose metal wants only 4. So this supports 4 only. How much lone pairs wanted metal, that is supplied. So that is a flexible donor. That is. Next. So ambidentate. So ambidentate ligands. So main important these are. So one by one we can discuss. Next, some chelate ligands also. That polydentate only you called as a chelate. Fifth one, polydentate or chelating ligands. See, bidentate, tridentate, more than one. These are also you called as a polydentate. So polydentate means poly means so many, dentate means donation. More than one donation also you called as a polydentate. So one special name is coming chelating. So or chelating. So chelating ligands, ambidentate ligands, flexible dentate ligands, that one by one we will discuss. So here the majority important is ligands only. So one by one we will discuss. First, based on the dentation. See, first in Roman letter, first one, what is based on that dentation. So first one, monodentate ligands. See, the ligand which donates only one lone pair. The ligand which donates only one lone pair. So the ligand which donates only one lone pair is called as monodentate ligand. Already we discussed every ligand is what? Positive, negative and neutral also. So that's why you can take negative mono. So negative monodentate. Monodentate, that will be negative charge. So you can take Cl minus, Br minus, iodine minus, OH minus. See, that is a name. The negative charge is ended with O. Negative ligand name is ended with O. So chloro or chlorido, bromo or bromido, iodo, hydrogen, oxygen and O. Hydroxo, like that. Next, amino. This is amino. This is hydroxo. This is chloro or chlorido, bromo or bromido, iodo. So like any negative charge you can take. So HCO3 minus 1 bicarbonate. Next HSO4 minus 1 bisulfate. So NO3 minus nitrato. NO2 minus 1 nitrito. CH3COO minus acetato. So like that. Any negative, the last name is ended with O. So that is. Next, B. Positive. Positive monodentate ligands. So they will donate only one lone pair with positive charge. So that is it. See, suppose NH2, NH2, hydrogen is there. So here one more. Actually here one lone pair, here one lone pair, you call it as a hydrogen. One H you added. So the lone pair is gone. So you are getting the plus. So this is called as hydrogenium. See, this name last is ended with IUM. So names. So positive. See, NO plus, it is called as nitrocerium. So some important. Next, neutral. So neutral monodentate. So neutral monodentate ligand, you take water. Water contains two lone pairs. Lone pair means that is electron pair only donated to the central metal. So this is called as aqua. Next, NH3 ammonia, you called as amine, A-double-M. So that example, suppose a pyridine. So organic based, so pyridine, PY. See, next carbon monoxide, that is a carbonyl compound. So the lone pairs without any charge, either positive and negative. Suppose here cyanide you take Cn minus. So you call it as a cyano, negative charge. So Nc minus, you call it as a isocyano. So like that, negative charge monodentate ligands, positive charge monodentate ligands, next neutral. Without any charge, they are readily donating lone pairs. So this is monodentate. Now, second one, we will discuss about bidentate. So bidentate ligand, the ligand which donates two lone pairs. So two lone pairs, that is called as bidentate ligands. So here negative bidentate. So negative charge bidentate ligands. So two lone pairs donation, next they must have negative charge. Oxygen O-2, so you call as oxido. So negative charge is ended with O. Next SO4 -2, that is what? Sulfato. SO3 -2, sulfito. Next CO3 -2, so carbonato. So negative charges, two members are donor. Next, so acetyl. See here, CH, COO minus NH. So actually it is a glycine. So glycine, it has a negative charge and one lone pair. Two members are donation. So this is called as a glycinato. So we are represented with GLY -1. Next, oxalato. Take COO minus, COO minus. So the name is oxalato. OX -2. So compulsory two donors. Otherwise two negatives, one negative, one lone pair. So like that also no problem. Next, positive bidentate. So positive bidentate, not much more available. So better you take neutral. So that B. Neutral bidentate. So ammonia only you take two members. So that means what? NH2 single bond NH2. So that is a hydrogen. So hydrogen, so it has two nitrogens, two lone pairs. These two lone pairs are donated. So pyridine is there. So one more pyridine you add. So this is a bipyridine. So simply they will show in future bi-P. So bi-P means a bipyridine, like that. Next, in between two nitrogens you put ethylene. So this is a famous CH2, CH2, NH2, and this side also NH2. So these two you call as ethylene. So this is the amine, this is the amine, two amines. So ethylene diamine, so indicated with En. So you must perfect these ligands. Because of your perfect means in next future nomenclature we are going to discuss. There it is more and more. So in the brackets they are mentioned En. En means you must remember it is ethylene diamine. So two CH2s and two NH2, like that you must remember. Next, third one, tridentate. So tridentate ligands. In this also negative tridentate. So negative tridentate. So now examples are decreasing slowly. See, NH here combining with CH2 COO minus, CH2 COO minus. See, two negatives donor, here one lone pair donor, total 3 members, but negative charge is there. Negative charge is there, 3 members are donor. So this is amino diacetato. So amino diacetato. So that is it. Next, neutral tri. So neutral tridentate. So previous 2 pyridines you are taken. Now you take 3 pyridines. So this is tri-P. So otherwise ter-P. So that means tripyridine. Next, triene also famous. Diene. So you take diene. Diethylene. Diethylene triamine. So the name itself is there. Ethylene. Ethylene means CH2, CH2. Diethylene. Yes, we are taken diethylene. Triamine. Amine. NH. NH2. NH2. So diethylene triamine. This is one ethylene. This is one ethylene. Diethylene triamine. So this is also 1, 2, 3. 3 members are donated. So 3 lone pairs. Okay, next we will discuss in next class.